So shifting a little bit, so I mentioned knowledge graph, and knowledge graph are mostly built on graph databases. So I'm not sure if you're familiar with databases, but the standard relational database is basically your Excel. It's like Excel. It's like sets of tables, and you put like information in there, and maybe this table is connected with another table by you put those connections via another table. So that's how like traditional relational databases looks like. But graph database is kind of built differently, wherein it actually looks at things, it stores things as a network. And the pros there is that first, it's easier to find hidden connections between objects. Then since it's a graph, it's a network. We can see hierarchies. If there are hierarchies in the data, we can easily see it. Um, easier to discover patterns and paths, and then we can also handle better complex many-to-many relationship. For example, as I mentioned earlier, a gene can be connected to multiple terms, and then the term is also connected to multiple genes. So there are like those many-to-many relationships, and it's kind of easier or it's faster, right, really, to query those relationships using a graphical approach. The cons here is that first, there is no uniform query language. So for relational databases, we have like a standard language called SQL. So that means if you're using one technology and another technology, you can communicate with them using a single language, and that's easy. You can work with one and another. You can easily translate whatever you want from like this different technologies. But for graph databases, we have different graph databases, and they all have their different language. You have to like learn how to like communicate with this one and that one differently. So they have like different nuances, different syntax, different language. And another con is that there is no optimize. It's not optimized for basic queries such as aggregation. So if you want to see, okay, if your graph has numerical values and you want to compute the mean of that, I don't know, like gene expression or whatnot across like these different values or connections, you can do it, but it's going to be a little bit slower than doing it like on a tabular format that we have for like Excel, the Excel example or the relational database example. So it's not optimized for that, but it's optimized for connections, patterns, hierarchies. So here are just some of the graph database products. So Amazon Snapshot, Infinite Graph, Allegro Graph, and Stardog. And of course, one of the more popular one is Neo4j, which is what we'll be focusing on today. So here are just some online resources about graph databases. So some introduction, and then comparisons between graph and relational database that I've kind of started a little bit earlier. So let's go with Neo4j that I mentioned. So Neo4j is a leading open source NoSQL native graph database. So when you just say NoSQL, it's just not in a tabular format that I was mentioning earlier. So it's in a graphical format, and that's how it stores the database itself. So it really stores it like this in the hardware or in the memory. So why Neo4j? First, we have the Cypher query language. I will discuss this later, but it's kind of really intuitive on how it does things. And I mentioned that there's no standard language between like this different graph databases, but there's also like this open Cypher movement wherein they're opening Cypher so that it can potentially be used on different tools or different technologies. And then the graph traversals is really fast. And we also have this flexible property graph, which I will discuss in a bit. And it has libraries for different programming languages. So you can use it for Python, you can use it for JavaScript and Java or whatnot. And like it has like different libraries and you can use it easily. So here's the property graph model. So here we have just an example wherein Go 005184 is associated with this gene SDF2L1 by the relationship maybe like from the library Go biological process. And so a graph The basics of a graph is that it contains two things, the nodes and relationships. So the nodes, these are usually tagged with labels, or I call it sometimes types or the roles. So this indicates the role of that node. So for example, this is a gene node. So that means that this node, SDF2L1, is a gene. Can also, this node is the type or the role is go biological process. So that's the role of that node. That's the type. It also has like a property. For example, we have like a gene ID or like the gene ID. So this is not the gene ID, but like whatever the gene ID of SDF2L1 is. And also G000511084 can be said as the gene ID. And it also has like an actual label, like the name of that node. Wherein, for example, like this go 005. I think this is the de novo one. So that's the label. And then SDF2L1 is maybe like the label, the gene label. Right. So it can have it can also be indexed and constrained. So indexing here, it just means that if we index things, we can do queries faster. So that's a good thing. Then we have relationship. We can sometimes you also call this edges, sometimes you call it links, and the idea here is these are the lines. And for Neo4j, it always has like a source and the target node. So that's where there's an arrow, there's a directionality here. But the good thing here is that directionality does not really affect the navigation or how you query stuff. So you can be agnostic with how you do your queries. And relationship can also have properties. For example, I just said here that the library is Go biological process. If you have information maybe of like gene expression or something, you can put it in there, you can add like different properties on like these edges, and which can also be searched. And one thing is nodes can have multiple edges without affecting the performance, which is actually really good. So now, let's go now to how we can translate our data to a network, to a knowledge graph. So let's go with the example of Enricher-KG, wherein we converted gene set libraries from Enricher into knowledge graph serialization. So here I'm showing you the format for serializing nodes. So the idea is we have two required columns, the ID and then the label. So the rest are optional metadata types. And then for the file type, the way I formatted it is we have like this node type .node.csv. So for example, the node type here is Go biological process. I just put that as a node type .node.csv. So that's how I will save this file. Next, we have the edge serialization, and it relies on triples. So we have like the source ID, the relation, and the target ID. And then the rest are optional metadata. And it should be formatted as follows. So node source type, dot relation, dot target node type, dot edge.csv. So for example, in here, I guess the source is the gene. So it will be gene dot go bp dot go biological process, that edge.csv. So as I mentioned, edge serialization relies on triples. So here you can see the first one is like a gene node, which is SDF2L1. So that's your gene and gene ID, and then the relation. And then your target is Go 0051084, which is de novo translational protein folding here. So these are your triples. So these three are your triples. The rest are optional metadata. And as I mentioned, so each of this source and target ID actually points to a specific metadata or to a specific row in your node.csv file. So for example, the Go 0051084 is pointing on this one. So if you want to explore that node, this is how it looks like. So here are like the additional metadata for that node. So let's try starting. So I'm just going to demo this. If you want to play around with it, you can play around. I have like the instructions here, but first we want to set up your Neo4j instance. So installation are available here. If you click in here, then you can can have information on how to actually install your Neo4j based on if you're using Linux, Mac OS, or Windows. But what I will suggest maybe is use Docker. So Docker is basically a way for putting everything inside a container wherein you don't have to worry if you're using Windows, if you're using Mac, if you're using Linux. Everything, all the requirements is in the Docker container. So it's easy. You don't have to like worry about prerequisites, installing stuff. It's all in there. You just have to install Docker. Uh, yeah, you can just go to like the Docker website and install it, and then you can clone this Neo4j image. And here you can see it's been downloaded at least 100 million times from the Docker Hub. So you can, so wherever reference you have, you can install Neo4j using these two methods. And just some prerequisites again. So we are going. I have like I have prepared what do you call this a repository for our demo. But so we're going to use Git. So first you want to check if you have Git in your system. So you just do git dash dash version. It should say you like a version if it exists. If not, then you have like options here on how to install. Here's for Mac and here's for Windows. And then make sure also Python is installed. So you do Python dash dash version. So it should show that it's Python 3. If it's Python 2, if saying Python 2 point something, then maybe try doing Python 3 dash dash version. So we should be using Python 3 because Python 2 is already deprecated. And here are just some installation instruction on how to install that too. So now, I'm using Visual Studio Code for like my text editor, but you can use whatever your favorite text editor you have. So first we want to clone this repository. So this is just the repository. GitHub.com and knowledge graph. Not this one actually. Knowledge graph demo. So here's everything that we need. So most of the stuff that we're going to use is in this notebook. So you're just gonna clone it using this instruction. It will return something that looks like this. Okay, so once you have that cloned, you go into CD there. So let me just go there. Where is it? Here it is. So ignore everything there. So just for example, cd dot dot, so clear. So you just cd to your knowledge graph demo, and then what you want to do is create a virtual environment. So running this so that we're kind of sandboxing everything, so that we're not going to affect your computer stuff. So we're just going to install everything in this venv. So Python 3 dash venv. So you're creating like this venv dictionary directory. So you can see here you have this venv, so you contain all your environment in there, and then you can run source. For Mac you can run source venv bin activate, and that will put you in your virtual environment. But I'm already in here, as you see here, so I'm not gonna run that. But yeah, that will put you in like in a sandbox environment. For Windows, you just run this one. And then next, what we want to do is install all our requirements. So that means we're gonna install everything that we need to do to run all of this notebook. So just run pip install -r requirements.txt. All right, so once you got that, we are now ready. So running Neo4j, as I mentioned, we can use Docker. So you can install Docker using this link. And then so the Docker compose file that we have here contains everything that we need to do to use to run this program. So we're using this Neo4j. Actually, we're using the Mayan Lab one that we kind of modified a bit. But yeah, but it's still, the base here is still like the Neo4j library. So yeah, we can use that one. And then so to run Neo4j, first we need to pull the image from Docker Hub. So you can do docker.-compose pull Neo4j. So I'm actually gonna run it here. So Docker compose pull Neo4j. It's already pulled, so it's kind of fast. But if you're doing it on your own and it hasn't been pulled yet, so it will download it from there, and then you're going to run Docker compose up on Neo4j, and that will run your Docker Neo4j. So it will take some time to load. Uh, yeah, it will take some time, but basically that's what we're going to do. So once you got that up, it will do something like this, and it will say started in here once it's ready for action. Yeah, there you go, started. So once it's started, you can actually go to localhost 7474/browser, and you will have something that looks like this. If it's empty, if the database is empty, you will just see nothing in here. So, but here I'm using Enricher-KG, my local copy for Enricher-KG, so that's why it has stuff in there. But if it's empty, you will have something. It's just empty in there. So we will work on how to ingest stuff, how to convert or how to serialize and ingest in a bit. So here are some online resources. So for Neo4j, some books and how to run Neo4j in a Docker container, so which might be useful for you if you want to learn more. Yeah. So as I mentioned, this is the Neo4j console, and this contains information on like you can put your code in here. You can do all your Cypher queries in here. You can also see the different nodes that are available and relationships that are available. So again, if you're starting from blank, you won't see this, but you can see here, you can click on that and it will return you some stuff. I will explain this a little bit more later, but I'll walk you through first on how to like serialize gene set libraries in nodes and links.